All right. So in the last video, we talked about if a squared minus b squared is equal to a plus b times a minus b, what about a squared plus b squared? Is there some sort of little identity that we get? Is this a squared plus b squared equal to something? Let's find out. Let's examine x squared plus 36. All right. Notice, is x squared plus 36 in the form of a squared plus b squared? If it is, what will it be? Well, let's see. Let's say let a equal to x and let b equal to 6. If we substitute, you see here we have a. If we substitute x for that a, you get x squared, right? You're substituting this x into that a, you get x squared plus 6 squared. That is equal to x squared is x squared. X squared is x squared plus 6 squared is plus 36. So yes, that x plus 36 is in that form of a squared plus b squared. Now, let's try and, the goal is to try and see if this is equal to something. Because we know that this is equal to this, and I'll show you why, right? So here is, we're examining this x squared plus 36. Is x squared plus 0x plus 36 the same as x squared plus 36? Are these two equal, right? And yeah, they're equal. You know, you have the x squared here, and here we just have a 0x. That's not 0 times x, that's just 0. So this kind of just, you know, it just stays there. You see, these two are just still the same, right? And then the 36 are there. So remember, if we have, let's examine this, right? If we wanted to factor this, right? What is our mantra? What was that mantra we say, right? What two numbers, when you multiply them, give you what? Give you 36, but when you add them, give you 0, right? Are there two numbers that you multiply them, they give you positive 36, and when you add them, they give you 0? Right? Think about it. And if you could find two numbers, write them down. Yeah, so just pause the video and try and think of those two numbers. Let's say you unpause the video and you're trying to find the solution, and you're thinking, Mr. G, I can't find it. You're right. No solution. You cannot find factors of 36, of positive 36, that when you add them, you get 0. It's impossible. Okay? So you cannot break that x squared plus 36 into some x plus some plus or minus something and x plus or minus something. You can't do it. You know, you just can't factor this. That's it. It's just, it is what it is. You can't break this down anymore. But when we noticed the last lesson, you had a squared minus b squared. That was a plus b times a minus b. Let's examine this. If we have that x squared minus 36, following that pattern, it's just, what will it be? It'll be x minus 6 and x plus 6, right? That's the pattern. But let's just take a look at this, for example. Is x squared x squared plus 0x minus 36 the same as x squared minus 6? X squared minus 36. Are these two the same? Right? They're the same. It's just that 0x, that's just 0, right? And now what do we say? Are there two numbers? Are there two numbers that, let's do the mantra, the same mantra up here. Are there two numbers that when you multiply them, they give you that negative 36, and when you add them, they give you 0? Are there two numbers? Absolutely. You have a plus 6 and a minus 6. That mantra, that rhythm applies to this. We can use that rhythm here in that form, and that's why we can factor this. But you see, this mantra, that rhythm, does not work over here. When it's a squared plus b squared, that rhythm will not work up here. But if you have some a squared minus b squared, you can break it to an a minus b and an a plus b. Okay? Yeah. you know, I thought this was important to kind of see. So thus a squared plus b squared is, this is what we call prime. This basically means cannot be factored. Cannot be factored. Okie dokie, cannot be factored. So going with that, let's look at, let's look at these examples. These are good examples to look at. So let's say we have this a to the fourth minus b to the fourth, right? Is this do you see a pattern, right? Remember, the goal of this whole lesson is kind of like is pattern recognition. Do you see patterns within factoring? Do you see a squared minus b squared inside here? Yeah, you could have some sort of, if you let a, you see here, if you let a equal to a squared, and I know that sounds very weird, right? You're saying, wait, a does not equal a squared. We're just saying you can substitute that a squared into here, and I'll clarify what that means. And let a equal a squared, and let b, that b over here, equal b squared. Okay? And I think if you're seeing this, you might be a little confused, but remember, this is just an identity. That's an identity. Remember that identity we learned about? But watch what happens. If you let a be a squared, what happens when you substitute a squared into this a? Oops, hold on, let me zoom in a little bit. This is really bad. Okay. I'll say that again. You see, this a, we're going to let a equal to a squared, and we're going to substitute that a squared into this a, right? Into that a. So what will happen? You have a squared squared is equal to a to the fourth, right? It's equal to that a to the fourth, so we're okay. And that b squared squared is equal to b to the fourth. Oh god, oops. I am just messing up right now, my bad guys. Okay, zoom in, yeah. So let me say that again, my bad. So that a squared squared is equal to a to the fourth, that a to the fourth over here. And that b squared squared is equal to b to the fourth, right? So you can break this using that a squared minus b squared pattern. So how would this break? This would break by a squared plus b squared times a squared minus b squared, right? This is the pattern. This is the rhythm that breaks it, okay? Now, great, you think, oh, we're done, but let's see. Can we factor this? Can we factor this anymore? This a squared plus b squared? Is it in the form of an a squared minus b squared where we can factor it, like a minus b or a plus b? This is, no, we can't. This is in the form of a squared plus b squared. And we just said previously that this is what? You cannot, this is prime, you can't factor this anymore. So this you can't factor anymore, but this, you can factor this. A squared minus b squared is equal to what? A minus b times a plus b. So this whole thing is equal to a squared plus b squared times a minus b, a plus b. Okay? A minus b plus b. And if you multiply this binomial times this binomial times this binomial, you get what? That original binomial up there. Okay? What about this one? How can you break this guy? Pause the video, try and do it by yourself, and yeah. All right. This will be what? Okay, let's say you want to come back. You let a, because remember, are we in some sort of a squared minus b squared form? Are we in that form? Let's see if we could put this into that form. What does a have to be? What does a have to be for a squared to equal x to the fourth? Oops. Oh god. Zoom in, I zoom in, it's off right now. Okay, let's just leave it like that. So I'll say it again. what does a have to be for a squared, that a squared, to equal x to the fourth? We want that a squared to look like that. Well, that's just equal to, let a equal to x squared. Because if a is equal to x squared, then a squared is equal to x to the fourth. Right? Because x squared squared is equal to x squared times x squared, which is equal to 2 plus 2 is x to the fourth. Okay? And now what do we want b to be? What do we want b to be? We want this b, like what does b have to be for b squared to equal 16? Let me write that. What does b have to be for b squared to equal 16? Right? B will have to equal 4 because b squared will equal 16. Right? And now we have that format. We can say that this is equal to x squared plus 4, x squared minus 4. Okay? And if you just had that and you're thinking, Mr. G, why did you go through this whole explanation? Remember, we're trying to show it in that identity form. And this is how you show it in the identity form. But if you're just able to see this very quickly in your head, then trust your head. Okay? Now let's look at this. Can we factor this anymore? X squared plus 4. Okay? We cannot. Remember that x squared plus 4 is in that a squared plus b squared form, right? Remember, something plus something in this format, you have to just start realizing using pattern recognition that you cannot factor this. But this guy, absolutely you can factor it. So we keep that x squared plus 4, and then this, is this in a form of a squared minus b squared? Yeah, this is just x minus 2, I'm sorry, x plus 2 times x minus 2. Even though it would have been the same if you said x minus 2 and x plus 2. But that's equal to this. Okay. These questions take time, okay? They take time. You start developing patterns. These 3 questions here, this one was really difficult. These questions are just pretty difficult. But I want you to try and do them. So pause the video and try and factor these. All right. Let's say you want to see the solutions. This is equal to x squared minus 1, x squared plus 1. Okay? And then this you can't factor, but this guy you can factor. This is x plus 1, x minus 1. And then you just have that x squared plus 1. Okay? Let's look at this one. The hint here was square root of 256 is 16. So this is equal to x squared plus 16 and x squared minus 16. And notice that this you can't factor, but this guy you can factor. This is x squared plus 16 times x minus 4, x plus 4. You see that pattern, that x squared minus 16, this pattern will be there. Okay, this one was a pretty challenging one. I couldn't find any other examples, so I thought I would make one up. Let's look at this. This will be x to the fourth plus 16, right? And x to the fourth minus 16, because that's the hint. If square root of 256 is 16, then 16 times 16 is equal to 256, right? You use that same pattern up there. This guy you cannot factor, but this guy you can factor. So let's see. This, well, let's just write this again. This is x to the fourth plus 16. And this guy is equal to x squared minus 4. I'm sorry, x squared plus 4 and x squared minus 4. Now let's see. This one we can't factor. This one we can't factor. Can we factor this one? Yes, we can. So it's just equal to x to the fourth plus 16, x squared plus 4. And then this is equal to x plus 2, x minus 2. And can we factor these two guys anymore? No, we cannot. Okay? All right. That's it. That's it. Any questions? Yeah. So just a summary. A squared minus b squared is equal to a minus b, a plus b, and a squared plus b squared is equal to, it's just prime. Cannot factor. Oops, cannot factor. Okay, I hope this helped. I'll see you.